Hey everyone, welcome back. In this session, we would understand a new concept, a concept called as methods in Java in detail. I have been reminding since the beginning of this course that what you refer to as methods in Java are nothing but functions in C, C++, and other programming languages. In other words, the concept of functions from those programming languages has simply been inherited as it is into Java, and after inheriting, it has simply been rebranded as nothing but methods in Java. Sir, are you trying to tell us that there is absolutely no difference between these two concepts, the concept of functions and the concept of methods? 100% no, that is not what I'm trying to convey here. There is obviously a little bit of a difference here, a difference to an extent of 0.001%. And what the difference is, do not worry about it at this point of time. By the time I conclude this concept, everything about functions, methods, and their differences you will be able to understand. But then, since 99.999% both of these concepts happens to be the same, obviously it is going to be a smart move here that if you would first understand the concept of functions in C language, then later on understanding the concept of methods in Java is definitely going to become a cakewalk for all of us. Now, before I dive into the concept of functions in C language, first and foremost, I would like to remind all of you about one aspect that I had already spoken during the discussion on history of high-level languages, which is nothing but the different programming styles, programming paradigms. And we know there are three popular programming styles that are high-level programming languages abide by, starting from the unstructured style. Next, we have the structured style, procedural programming, functional style of programming. And lastly, we have definitely got the object-oriented style of programming. Now, let us immediately dive into the concept of functions in C language, before which I would like to understand what led the creators of different programming languages at first introduce this feature called as functions in their programming languages. In other words, I would like to understand the origin of functions. What was the need for this particular concept in those programming languages? For which we will have to once again understand the difference between unstructured style of programming and a structured style of programming. Now, speaking of unstructured style of programming, let us say I have got a certain task here. And if I would like to implement the code for this particular task in the unstructured style of programming, how would the code in that case look like, sir? What do you mean to say, sir? Please understand this. Let us say to implement this particular task, I will have to be writing 10,000 lines of code here. And in unstructured style of programming, how would the code base, which is containing 10,000 lines of code within my application look like, sir? This is how it is going to look like. And please understand, this is where the catch is. In unstructured style of programming, all of these 10,000 lines of code would be considered as a single block of code. But first of all, what is meant by a block of code? A block of code is nothing but set of statements. It is a piece of code that is surrounded with a pair of curly braces. But sir, we have seen so many blocks of code previously. We have seen there is something called as the if block, else block, switch block, for block, the while loop block. Which block of code are you trying to refer to here? I am not referring to all of those blocks of code here. The block of code that I'm trying to refer to here happens to be a function. And like I said, in unstructured style of programming, how many blocks of code are going to be permitted? Just only one block of code. In other words, I would be able to place just a single function within which all of these 10,000 lines of code are going to be dumped. And you know, for any application to be executed, compulsorily, we need a function called as the main function. But in this case, since only one function is permitted to be created, obviously I have got no other option left out with me. I have to definitely make sure that one function happens to be the main function like this. In other words, I once again repeat, in unstructured style of programming, how many functions are permitted to be created? Just a single function. And doesn't matter whether you have got 10,000 lines of code or 1 million lines of code. All of those 1 million lines of code, we have to dump it inside that one single function that we would be creating it. What really is the problem with this, sir? I think by this time you should have realized what the problem with this particular style of programming would be. If those many lines of code would be dumped inside a single function, 100% managing the entire code base would be extremely difficult. Let us say tomorrow I would like to upgrade my application, slightly I would like to modify the code base. Extremely difficult because there are so many lines of code. Also, if in case there are any errors within my application code here, to debug it, to identify which line is generating the error and to rectify that particular mistake, once again it is going to be humanly impossible. We will have to go through every single line of code within my application, 10,000 lines of code. I have to keep visiting one by one, and I'll have to find out which particular line is generating the error, and then I'll have to debug it. Extremely difficult. Also, the major disadvantage here is it is going to make the code hardly readable. It is going to reduce the readability of my application code here. Also, if you ask me, how would these 10,000 lines of code be executed? Obviously, they're going to be executed one after the other. In other words, in the sequential manner like this. This style of programming, my friends, is what we refer to as the unstructured style of programming or the non-structured style of programming. Now, let us speak about the structured style of programming, wherein let us say, this time, this is the task that I have got. And I realize this happens to be quite a large and a complex task. Maybe we have been given the task to implement the entire Facebook application. Maybe we are working with Mark Zuckerberg. We are a part of the core team of Facebook. Now we have to start implementing the Facebook application. In unstructured style, all of the lines of code for that particular task would be dumped inside a single block of code. But in structured style of programming, this happens to be the approach. The very first step is the large and the complex task, first and foremost, should be divided into smaller subtasks. What do you mean to say, sir? We know that the Facebook application, it is composed of so many different independent functionalities. For example, we have a subtask within the Facebook application called as the login functionality. This is a completely independent functionality altogether. Similarly, there is another subtask called as send friend request. Maybe I would identify another subtask as change profile picture. And finally, we also have the logout functionality here. So this is the first step here. Given a task, in case of structured style of programming, I will have to identify the smaller subtasks and divide my entire larger task into those smaller subtasks like this. This happens to be the very first step. Sir, great sir. We have done those division here. We have identified what are the independent functionalities. All of these functionalities combined together is what would lead to create an application called as the Facebook application. But then, how are we supposed to implement each of these smaller subtasks? Congratulations, my friends. That is when you will have to make use of a concept in programming called as functions. And this term called as functions, it has got so many synonyms associated with it. That means different names, but all of these terminologies would convey the same meaning here. What you refer to as functions, they're also referred to as procedures, routines, modules, subprograms. In fact, they are also referred to as methods. Anyways, sir, in structured style of programming, how would my application code base look like? Please understand, this is how it is going to look like. wherein each of these functionalities would be implemented as a separate function altogether. But like I had mentioned, every single application compulsorily needs a function called as the main function to launch the application. Hence, maybe this is the code that is going to help us launch the Facebook application. And this piece of code, I would immediately place it within a function called as the main function like this. Next watcher, next I see there is a smaller subtask that I have identified here called as the login functionality. Hence, whatever code that would help the user to successfully log in into the Facebook application, this is that piece of code, and I would place it within a separate function altogether called as the login function like this. Similarly, maybe this is going to be the changing profile picture functionality that I have coded it as a separate function altogether. Similarly, this is our send friend request function, and finally this is our logout function like this. And if you ask me, would the execution control flow in unstructured style compulsorily be sequential? Definitely no. In case of structured style, the control can jump from one function to another function and execute that other function, and it can come back to the point where it had gone from. In other words, maybe this is how the control flow is going to look like. As you can see, it is moving from one function to another function. This is the liberty that we have been given in case of structured style of programming. And congratulations, this style of programming is what is technically referred to as structural programming, procedural programming, modular programming, functional programming, and there are many other synonyms given to this. And of course, speaking of the advantages of structured style of programming, it is going to be quite easy to manage the code. Let us say this time, I would like to do some changes with respect to the login functionality here. Think and answer. Do I have to really make changes to the entire application code base just randomly anywhere? 100% no. Since it has been coded in this case as a separate function altogether, immediately I would go to the login function, and only inside that particular function the changes would be done. Easy to modify. Similarly, it is going to be easy to debug. Obviously, it is going to increase the readability of my application code here. These are the advantages of the structured style of programming. Now that we have been able to clearly distinguish between these two styles, unstructured style and the structured style of programming, between these two approaches, which style of programming do you think is going to be better? It is best suited irrespective of the kind of the task that has been assigned to us. Always, this is the style of programming that we need to opt for, sir. Which one do you think is going to be better? And without giving it a single thought, if your answer happens to be structured style of programming, let me tell you, you have made a smooth landing into the trap that I had laid for all of you here. What do you mean to say, sir? Especially during the interviews, if such a question is asked, please do not fall to the trap and do not favor one concept over the other. That means what you're trying to basically tell me here is, all of those inventors of the programming languages whose languages follow the unstructured style, all of those inventors were less smarter than what we are. That is what you're trying to conclude here. That is definitely not the case. They were all computer scientists, one of the smart people who ever walked on the planet Earth to have created a programming language. In other words, both of these two styles of programming have got its own pros and cons. What do you mean to say, sir? If in case I have been assigned a small task, it is a simple task, why would I simply scratch my head and try to break that smaller task into even more smaller subtasks? 100% it wouldn't be needed. In that case, I can opt for the unstructured style of programming. But let us say I have been assigned with a large and a complex task. In that case, I undoubtedly have to go ahead with the structured style of programming. So it depends on the scenario. Small task, unstructured style. Large and a complex task, undoubtedly it would be the structured style of programming. This is how your answer also has to be. Maybe with this simple analogy, you should be able to remember the differences between these two approaches, and most importantly, you should be able to remember when to opt for the unstructured style and when to go ahead with the structured style of programming. And what is that analogy, sir? Let us say one fine day I have decided to invite all of my students at my place. And once all of you have arrived, to each one of you, I have decided to offer a plate of pani puri like this. But before you start consuming it, I make an announcement that look, each and every Golgappa piece, you have to eat it in one gulp, in one shot. Would it be possible? 100% yes. Because the size of the Golgappa happens to be so small. Naturally, we have always been used to eating the Golgappa, each and every piece in one gulp. Basically, it is the unstructured style. That is the approach that you have applied here. Let us say for a change, instead of offering golgappas to you, I have decided to offer one of the favorite South Indian dishes, which happens to be masala dosa like this. And here also, before you start consuming it, I have made an announcement here that look, the entire masala dosa in one gulp, you will have to eat it. Tell me, would there be any student of mine who would be ready to eat masala dosa in this style? 100% no. Can you tell me what would be your natural instinct when it comes to eating masala dosa? Absolutely correct. We break down the masala dosa into smaller pieces, and that is how we have always been used to consuming it. In other words, the approach that you have applied here, undoubtedly, it is the structured style. If it is a small task, go ahead with the unstructured style. If it is a large and the complex task, in that case, we immediately divide it into smaller subtasks, and those smaller subtasks, we independently implement it. In other words, it is nothing but the structured style of programming. Now, just because for some of you, the structured style happens to be the favorite style of programming, it doesn't mean you have to apply it in every given scenario. What do you mean to say, sir? Let us say, since your favorite style happens to be the structured style, if you start applying the same for the case of Pani Puri here, that means instead of consuming one Golgappa one at a time, you will start breaking into smaller pieces. Will you be able to enjoy the actual taste of Pani Puri in that case? Certainly not. Hence, you will have to be smart enough to realize, depending on the scenario, which approach has to be applied. Right. Whatever we have been able to understand so far with respect to these two approaches, I would like to jot it down at one place, and I would like to list all of the features of these two styles of programming. So please observe, starting with the unstructured style of programming. We know that in this style of programming, the programs are going to be coded as a single block of code. As a result, it is going to make the code hardly readable. And undoubtedly, it is going to be extremely difficult to modify and debug in this style of programming. And some other features of unstructured style of programming happens to be these two features. But most importantly, we know that this style of programming is going to be suitable for small and simple projects. But sir, can you give examples of such programming languages that follow the unstructured style of programming? Absolutely yes. The earlier versions of a language called as BASIC, another language called as COBOL, another language called as Fortran. All of these languages follow the unstructured style of programming. Now, speaking of the structured style of programming, we know in this case, the large and complex programs are going to be coded as small blocks of code. In other words, the application is going to be divided into smaller subtasks. Hence, definitely it is going to make the application code base a lot more readable. And some of the other features of structured programming styles happens to be these two. And most importantly, this style of programming is going to be suitable for large and complex projects. But then, sir, those smaller blocks of code that you're trying to refer to here are going to be implemented as nothing but functions. Hence, now it is time, after almost discussing for around 15 minutes now, we have to provide the definition of this component within our program called as functions. Hence, what really a function is, we know that those smaller blocks of code are going to be implemented as functions. But what is a function? A function is nothing but a block of code. It is a collection of statements which are grouped together to perform a certain task or an operation. But please remember, a function will not be automatically executed. For a function to be executed, it has to be called. It is something like this. You might have some problem with the sink in your home. But if that has to be fixed, just by saving the plumber's number in your mobile phone, the problem is not going to be fixed. If you want the plumber to visit your home and fix the issue there, what is it you should be doing? You will have to call the plumber. In the same manner, if you simply define a function, it won't be automatically executed. For a function to be executed, what is that we must be doing? We have to call it. Anyways, sir, examples of structured programming languages. These are some of the examples. Perfect. Now that we have been able to understand the very origins of the function, and through which we have also been able to understand as to what is the definition of a function, I would once again repeat, a function is nothing but a block of code or set of statements that are grouped together to perform a certain task or operation. Sir, what do you mean by task or operation in the context of a function? I'm sure all of you are able to remember when I was explaining the structured style of programming, we had taken the Facebook application as example, wherein we had seen there were so many different functions: login function, change DP function, send friend request function, logout function. For example, send friend request happens to be the name of the function, but can you tell me what is the actual task or operation that function will be executing whenever it is called? Absolutely correct. It would simply send a friend request to another person that you are planning to connect with. That means for every single function, definitely there would be a certain task or operation in mind, keeping which you would have defined that function. Anyways, it is now time that we move forward and understand how do we create a function within our program. In other words, what is the syntax of functions? Please remember, a function must and should have the following 4 components. What are those, sir? First one, obviously, it is going to be the name of the function. But sometimes you can also have such functions which would be expecting input from the caller. But please remember, it is not compulsory that every single function should have this component. It depends on the type of functions that you're trying to define. Anyways, the second component happens to be the input to the function, and the third component happens to be the actual task or the activity that the function would be performing. And lastly, just like how a function can receive some input, it is also possible that a function can also send some output. A value can be returned from a function back to the caller. Basically, output also can be sent from the function. Now, whatever theoretically I have listed here, if I would organize all of these components, how would the syntax look like? Please remember, this is how the name of the function has to be specified here. And please remember, immediately, always after the name of the function, it must be followed with a pair of parentheses like this. And it is in between these parentheses, you will have to specify if in case this function would be receiving any input from the caller. But sir, whatever activity or the task that the function would be performing, where are we supposed to specify that component? It must be specified here, and this must be specified as a block of code like this. And all of you know what is a block? It is nothing but a piece of code that is surrounded with a pair of curly braces. And what about the output, sir? The last component must be specified here just before the name of the function. Now please understand, this is how the syntax of a function would look like from a non-technical aspect. And the same thing, if I would have to express it technically, then please understand, the name of a function, both non-technically as well as technically, would remain the same. And in between those parentheses, whatever input that a function is going to be receiving from the caller, that input, technically, we refer to it as parameters like this. And the activity or the task that the function would be performing, technically we refer to it as the body of the function. And whatever output the function would be returning back to the caller, that is what we technically refer to as the return type of the function. This is how technically the components of a function are supposed to be explained. Please understand, this is what, my friends, is referred to as the function definition. But we also know only the function definition is not enough, because only if you define the function and leave it as it is, magically the function won't be executed. For a function to be executed, you need to invoke the function, you need to call the function. Now, what is the syntax for the function invocation, sir? It is very simple. All that you have to do is, first and foremost, give the name of the function, whatever is the name of the function. And if in case it happens to be such a function which would be expecting parameters, in which case whatever data that you're going to be sending as input to the function, technically we refer to it as arguments. That must also be specified it here like this. This is how the syntax of a function call is going to look like. I once again repeat, in this case also, the arguments are not mandatory. Only if the function that you're trying to call would be expecting parameters, only in that case you should be sending the arguments like this. I hope all of you have been able to understand the syntax of both function definition as well as function invocation. But sir, we are unable to differentiate between these two components here, parameters and arguments. Please understand, parameters simply means the variables that are defined in the function definition. But arguments means it is the actual data, hard code value that you're going to be sending as input to the function that would be collected by the parameters. That is the difference between parameters and arguments. Perfect. Now that we have been able to understand as to what is the syntax of function definition and what is the syntax of function invocation, it is now time that we realize that functions as a concept would bring two major advantages to the table. And what are those two advantages, sir? Please understand, within your application, using the concept of functions, we will be able to implement two major advantages of it, which is we will be able to achieve something called as code modularity within our application, through which I will be able to organize different functionalities within my application. And also I will be able to achieve something called as code reusability, through which I can ensure the redundancy within my application is going to be drastically reduced. What do you mean to say, sir? Do not worry about it. How do we reap both of these benefits within our application programmatically? That is what next I would be explaining. Starting from the very first advantage of functions, which is the code modularity. Now, to understand how can we implement this practically within our application, let us take up a sample program here, which is a program to add and subtract two integer numbers. Basically, it is an addition subtraction program here. And to implement the solution to this particular program here, I wouldn't be using Java as the programming language. Since we are discussing everything about functions of C language, let us also try to implement the solution in the same language, which is C. And also, I would like to implement the solution in two different styles. The first one is going to be in the unstructured style. And later, the code of the unstructured style, we would take it as it is and we would try to convert it into the structured style. Let us immediately start with the unstructured style, wherein all of us are aware of the fact here that in the unstructured style, I am permitted to have only a single block of code. In other words, I am allowed to create a single function. And obviously, since I would also like to execute my program, that one single function is going to be none other than the main function, in which case this is how the program code is going to look like. Don't worry, it is a simple piece of code. I would also give you a walkthrough of every single line that is present within this particular program, starting from the very first statement that is present within my main function. If you notice, in the very first statement, we have declared two variables A and B, and the purpose of these two variables, it is to receive the integer values that are going to be provided as input to my program. As simple as that. In the next statement, I have also declared two other integer variables, sum and difference. These two integer variables, going by the name of these variables, would be holding the result of addition and subtraction operation respectively. And after which I would like to make an announcement to the user on the monitor screen. That is why we have a printf statement there, wherein I'm simply trying to print a message. Please enter the two numbers to add. And after reading this message now, the user is ready to key in the two integer values, which I will have to scan it within my program. That is why in the next line, I'm trying to call a function called as the scanf function, and through which I would read both of the integer values, and I have successfully stored it within the input variables a and b respectively. And after this, the only activity that I should be performing now is, since I have already received the input here, I need to perform the addition operation between the integer values that are stored in the variables a and b. That is what I'm trying to do it in the next line. And the result, as you can notice, I'm trying to store it within a variable called as sum. And the last thing that I need to do here is the result has to be displayed back to the user onto the monitor screen. And the remaining set of statements would be performing the similar activity, but the only difference is it would be performing the subtraction activity. And all of these statements, as you can notice, I have dumped it inside a function called as the main function. And since within my program, I'm also making use of printf and scanf inbuilt functions here. That is why at the beginning of my C program, I need to include a preprocessor directive statement here, which is nothing but the hash include statement. That also has been included. Now, if you would ask me, how would all of these lines of code be executed, Zabi sir? The answer is very simple. All of these statements would be executed sequentially, one after the other, like this. And once all of these statements within your main function have been executed, the program is going to be terminated, and we would also be able to see the output onto the monitor screen. Great, sir. We have understood the unstructured style approach. How about the structured style? Now, before we move on to the structured style, I hope all of you remember the thumb rule of structured style, which is, before you start writing the code, you will have to first and foremost identify the different subtasks that are included within your application. And in this particular program, I see that here we have got three different subtasks. And what are those, sir? Addition, subtraction, and execution. Whatever statements using which you are trying to read the input, and whatever statements through which you are also able to display output onto the monitor screen, all of those statements we would obviously put it within our main function. In other words, now that we have identified three tasks, each of these three different tasks would be implemented using a separate function altogether. In other words, starting from the main function, this is how the main function in structured style would look like. The first four lines within my main function happens to be the same: declaration statements, print statement, and the scanf statement. After which, directly within my main function this time, I don't want to perform the addition operation. Since it is a completely different operation, a completely different task, I would like to perform this particular activity using a separate function. In other words, I would want to escalate the job of performing addition operation to a different function called as the add function. Similarly, the job of performing the subtraction operation would be handed over this particular responsibility to a separate function called as the sub function. But where are those two functions, sir? Correct. Makes sense. Please observe this. These are those two functions here. And since once again within my program, I'm making use of the printf statement and the scanf statement here. Obviously, at the beginning, I have to add this particular hash include statement like this. Great. Next word, sir. Though we have three different functions here, can you please tell me from which function is the execution going to start? The answer is quite simple. Obviously, the execution would start from the main function like this. And once the control would have executed all of these four lines within my main function, after which now I would be interested in performing the addition operation. But at the same time, like I said, I don't want to directly use the plus operator within my main function and perform the addition operation. To perform the addition operation, we have a dedicated fellow who is ready to do the job for us. who is nothing but the add function. But we also know one of the important characteristics of the functions, which is if you define a function, they won't be automatically executed. Whenever you would want any function to be executed, what is that we must be doing? Very good. We must call the function. Without we placing the call, the function will not be magically executed. But how do we call a function, sir? All of you know the answer, using the name of the function. But at the same time, there is something unique with respect to the add function here. If you notice, my add function is such a function which is also expecting two integer values as input, because it is common sense. If you'd say to the add function to perform the addition operation, how will it be able to perform the addition operation without you sending the data to it? That is why whenever I have to call the add function, compulsorily by looking the definition of the add function, I see that there are two parameter variables who are waiting to receive the integer values. That is why whenever I am placing a call, I should also be sending two integer values. In other words, this is how the add function call would look like. Let us say when the main function was executing, the user wants to perform the addition operation between these two integer values 10 and 20. Those two integer values, through the scanf statement, they would have been scanned within my C program and they would have stored within the variables A and B respectively. Now in this particular statement, while I'm calling the add function, all that I'm trying to do here is whatever integer values are present within those two variables, which is nothing but 10 and 20, the same integer values I am also trying to send to the function definition of the add function. And please remember this fundamental rule here, which is whenever a function is going to be called, the first thing that would happen is immediately from that point within your program, the control would be transferred to the function body. And as all of you know, in this particular case here, only the control won't be transferred. Along with the control, since we are also sending the input here, the values present within the variables A and B, I am assuming in this case it is going to be 10 and 20. The data would also be sent. That is why already in the function definition, the framework was already prepared. Nothing but the parameters were already declared within the add function. Now it is those parameters who would be receiving the input integer values here, which happens to be 10 and 20 respectively. And once the parameter variables are going to receive the data, now immediately the control would enter the body of the function. And as you can notice, inside the body of the add function, in the very first line, we are trying to perform the addition operation between the integer variables x and y. Obviously, they're holding the data 10 and 20. The result obviously is going to be 30, which I have in this particular function stored it within a variable called as res. And in the next immediate statement, as you can notice, there is a statement called as return the value of res. That means the add function does not want to keep the result of addition to itself. It wants to return the result back to the caller here. And who is the calling function here? Who is calling the add function? It was your main function. So the main function here is going to be treated as the caller. How can a function return a value to the caller, sir? Simply by using a special keyword called as the return keyword. That is why if you carefully observe here, since you are returning an integer value, because tell me what is there in res? It is nothing but 30, which happens to be an integer value. That is why very smartly I have also defined within the add function here that the return type of the add function happens to be int. Why? Because it is returning an integer value. In other words, because of this return statement, immediately the control leaves the add function and the control comes back to the same place from where it had gone to the add function. In other words, within the body of the main function. But as you can notice here, it has not just come back. Along with the control, it is also coming back with an integer value called as 30. Now it is our responsibility within our main function, we have to receive this integer value called as 30 that is coming back from the add function, which is the result of calling the add function. That is why very smartly within my main function, at the beginning itself, I had declared two variables called as sum and difference. Hence, it is this variable sum using which I will be able to collect the value which the add function is returning to me. And after which, the only thing that is pending with respect to the addition activity here is I have to simply print the value of the variable sum, which is the result of addition operation, back to the console screen like this. That is what this printf statement would be doing for us. Now that you have been able to understand the addition activity, similar fashion is what the subtraction activity would also be implemented, wherein these are the statements that would help us achieve the subtraction activity. And as you can notice here, now that the control has come back to the main function, the rest of these statements would be executed. And immediately it is in this line. Once again, I have encountered a function call. This time, which function am I calling? Sub. So what would happen, sir? All of you know, the first thing, control would immediately be transferred to the function body. At the same time, I'm also sending some input here. So those input values would also be sent along with the control, which would be received by the parameters x and y. And once again, after executing the sub function body here, it would be coming back with the result of the difference operation here. And that value along with the control will once again come back to the main function. The value is going to be displayed onto the output screen, and after which the program is going to be terminated, because all of these statements within my main function have been successfully executed, which indicates the end of the program. The program is going to be terminated. This is how a program can be written in the structured style, where different operations have been implemented using different functions. And this process of whatever we have done here, this activity, this is what, my friends, is referred to as modularization. A program code that was dumped inside a single function has been taken and it has been converted into three different functions. This is what is called as modularization, and through which we have been able to definitely achieve code modularity. But most importantly, if I would ask you this question here, if I would execute both of these approaches, do you think would there be any difference in the output of the unstructured style program and the structured style program, or do you think the outputs of both of these programs are going to be identical? Definitely, the outputs of both of these programs is going to be obviously the same. They would be exactly the same. And how would the output look like, sir? This is how it is going to look like. Now, please don't ask me whether this is the output of unstructured style or whether this is the output of structured style. For both of the approaches, the output would look exactly the same. Then, what really is the difference, Zabi, sir? Please remember this. From the end user's perspective, who are going to look at only the outputs of both of these two programs, they would not be able to make out any difference at all. Because the difference in this case lies in terms of the approach that the developers have followed in order to provide the solution to the given problem statement here. Because please remember this, sometimes only pleasing, satisfying the end users wouldn't be sufficient. You will have to evolve yourself as a skilled developer who knows that how to organize the code within your application, how to efficiently try to implement the solution. You know that at the same time, while pleasing the end users, you should also make sure that the system resources are going to be efficiently utilized. In simple words, in case of structured style, as you could notice here, for every single functionality, we have implemented it as a separate function. Hence, managing the code becomes definitely very easy. We have organized the application code base in such a way that tomorrow, if at all you would like to perform any kind of upgradation to any of these functionalities, you know exactly which function has to be modified, while rest of the code within your application remains untouched. This is what, my friends, technically it is referred to as code modularity. And how did we achieve modularization within our application? Definitely by using the concept of functions. And I'm also sure this word called as modularity, it is completely not at all new to all of you here. I'm sure this word has definitely fallen many a times into your ears. Especially whenever you would have seen somebody while constructing a house, they would have told to you that the design for the kitchen, whenever they would approach any kind of an interior consultant, they would have made sure that the kitchens that are going to be built within the homes are going to be modular kitchens. What are these modular kitchens, sir? Please understand, this is how the non-modular kitchens used to look like, the traditional kitchens, where there is no separate section that is going to be built for you. You will have to yourself place the items wherever you want. But in case of modular kitchens, the things are going to be slightly different. Where, as you can notice from these beautiful pictures here, there are going to be separate sections that are dedicated for one type of utensils, for one type of vessels are going to be built. There is going to be a separate section where all of these spoons are going to be placed, separate section where all of the glasses are going to be placed. There is a separate section where you would be arranging all of the plates. Tomorrow suddenly, if I am looking for a glass, I know in the kitchen in which corner, inside which section I will be able to find that particular item. Since it has been organized so beautifully, whenever I need to access something, it is definitely going to become a lot easier for me. Anyways, I hope with this all of you have been able to understand as to how to achieve code modularity using the concept of functions. Now it is time that we move on and try to explore the second advantage of functions, which is nothing but code reusability. Whenever you would want to use a certain piece of code within your application again and again, repetitively, in that case, you can make use of the concept of functions. But sir, we remember from our previous discussion on control constructs, you had explained to us whenever a certain piece of code should be repeatedly executed again and again, again and again, we actually have to make use of something called as looping statements, nothing but loops. Then, sir, can you please explain to us in what context we have to go with loops and in what context we have to opt for functions? What really is the difference between loops and functions? Because using both of them, we will be able to achieve code reusability. That is what I'm trying to explain. Please concentrate and understand here. Let us say this is how the structure of code within my application is going to look like. Wherein at the beginning, there are some 100 unique, distinct lines of code doing some activity. And after which, there is a certain task called as task A. It could be addition, it could be subtraction, login, logout. Here, for the sake of simplicity, I have simply called it as task A. And to implement this task A, we would have to write 50 lines of code. And as you can notice here, same task A should be executed 3 times at the same place within my application. And after which, at the bottom of the code base here, there are another 100 unique lines of code. In this case, as you can notice here, same 50 lines of code have been coded 3 times within my application, definitely, which is not at all appreciated, because redundancy within your application should be close to minimal or close to zero. It should not be there. You will have to eliminate as much as possible. Redundancy means duplicate code. You see in this case, same 50 lines of code. How many times have I written it here? 3 times. Not at all appreciated. So what do we have to do, sir? To ensure the same 50 lines of code can be reused again and again, do I have to make use of functions or loops in this case? Please understand, in this case, since those 50 lines of code for task A are going to be executed multiple times at the same place, at the same instance within your application, you will have to opt for loops, wherein you will have to write those 50 lines of code just once, like you can see. And then you will have to enclose it within a loop of your choice, for loop, while loop, do while loop, any loop of your choice. And then you will have to make sure the loop is going to iterate for 3 times. Done. This is the solution in the first case. Now, please understand the next case here, wherein maybe this is how the structure of program code within my application is going to look like. And if you would carefully observe here, in the second case also, I would like to execute task A 3 times. But if you would ask me, what is the difference between the first case and the second case, Zabi sir? In the second case, I am executing task A 3 times, there is no doubt about it. But the difference is task A is being executed repetitively at 3 different places. Hence, to optimize the application in the second case, 100% I won't be able to make use of the looping control constructs. In this case, to bring in efficiency within my application, undoubtedly I will have to go ahead with the functions concept here, wherein those 50 lines of code for task A should be coded only once, because I don't want any duplicate code within my application. And this time you will have to enclose it within a block of code called as a function. Next what, sir? After which the application code would look something like this. But once the first 100 lines of code are executed, before the next set of 100 lines of code are executed, in between, task A should be executed. But are you going to repeat the 50 lines of code once again here? 100% no, since it has already been enclosed within a function. But I hope you're also understanding this is not a Marvel series here that the function would be magically executed with a snap of a finger. You will have to call the function. And how do we call the function? All of you know the syntax. I would simply say we will have to call the function. After which, after executing the next set of 100 lines of code, once again I want the same task A to be executed. That means, sir, can we define a function once and can we call it multiple times? 100% yes. A function can be called any number of times. Once again, I would place a call to the function, and at the last also I want task A to be executed. Hence, simply I would be calling the function once again like this. I hope with this beautiful explanation here, all of you have been able to realize what is the difference between loops and functions, because using both the concepts, undoubtedly I will be able to achieve code reusability. But you will have to be a smart developer to choose between loops and functions depending on the situation within your application development. If the task is going to be repeated multiple times at the same place, go with loops. If the task is being repeated but at different instances within your application, in that case you will have to go with the functions approach. Great. Now that we have been able to understand the second advantage of using functions, which is nothing but code reusability, but we have understood this diagrammatically, let us also try to understand the same programmatically, for which we will take up this simple program here, wherein given a particular alphabet as input to my program, I will have to give the output whether it is a vowel or a consonant. One of the commonly asked interview question it is going to be, all of you know what are vowels in English alphabets? 5 characters A, E, I, O, U are going to be considered as vowels, and the rest of the 21 alphabets of the English language would be considered as consonants. Let us say this is how I would like to implement it without implementing the benefit of code reusability within my program code. What do you mean to say, sir? This is how my program code would look like traditionally. There are some 100 lines of code at the beginning. Now, after which immediately I would like to check whether the character yes happens to be a vowel or a consonant. And how are we going to implement that piece of code, sir? It's a simple logic. This is how you're going to be writing the code for using the switch statement. For all of the 5 cases, A, E, I, O, U, we would simply print it is a vowel. If otherwise, we know the default case would be executed, in which case consonant would be the message that is going to be displayed. After which, once again, there are few unique distinct lines of code that would be executed. And after which, all of a sudden now, once again, I would like to check whether the character I happens to be vowel or consonant. That means the same logic has to be applied once again. In other words, the same piece of code should be repetitively executed like this. And after which, at the last, before I conclude the program here, once again I would like to check whether the character M happens to be vowel or a consonant. Once again, derive the same logic, execute it. Definitely in this case, the programmer is not at all aware of the concept of functions, because clearly there is redundancy within his application code. He doesn't know how to utilize the concept of functions, through which how do we reap the benefit of code reusability. And how are we supposed to reap that particular benefit, sir? All that you have to do is, since you see this logic of trying to find out whether a character is a vowel or a consonant is being executed repetitively within my application, I would implement that logic only once and I would place it within a function like this. As you can notice, I have created a function called as check alphabet. You give any character to my function, it will tell you whether that character is a vowel or a consonant. And what about the main function, sir? This is how it is going to be implemented. Now, all of a sudden, after the first 100 lines of code, do you want to check whether the character yes is a vowel or a consonant? Don't derive the logic once again. Simply call this function check alphabet like this and pass the character yes. You will get the answer. Suddenly, somewhere in between, do you want to check whether the character I is a consonant or a vowel? Simply call the function like this. And at the last, do you want to check whether the character M happens to be a vowel or a consonant? Once again, call the same function. I hope with this another beautiful example you have been able to programmatically get a sense of how can we achieve code reusability within our application code using the concept of functions. So to conclude, these are the different advantages of functions. Now, finally, after discussing functions in C language for almost an hour now, it is time that we can come back to Java and understand what are these methods in Java. Like I had claimed at the beginning of the discussion, that whatever you refer to as methods are nothing but functions of the predecessor programming languages, and in both of the concepts 99.99% everything is same. There is just a difference of 0.001%, and what really is that difference? It is now that you will be able to understand after almost 60 minutes of introduction for this particular topic. Trust me, in no YouTube channel, on no website on the internet, in no finishing school, they would have given you 60 minutes of introduction only to speak about methods in Java. Anyways, I'm hoping that all of you would value the efforts that all of the mentors are putting into this particular course, and you will also reap the benefits from this course, just like how we are reaping the benefits of functions in programming. Anyways, long back, while I was explaining object orientation, there I had spoken about 5 rules of object orientation. In the last principle of object orientation, I remember speaking about that every object in the real world is going to have 2 parts. What are those 2 parts, sir? There is something called as the has part. We also have something called as the does part. And the has part is what we technically refer to as the state or properties of an object. And the does part is what we technically refer to as the behavior or the activities that are going to be exhibited by the objects. And in Java, to handle the has part, we have to make use of a concept called as fields or variables. Till the last discussion, this is what the entire discussion was on variables, data types, the operators. That is what we are trying to understand. Now, in order to implement the does part within our Java programs for any given object, that is when, my friends, we have to make use of something called as methods or functions. I hope all of you remember we had seen so many object examples: dog object, fan object, student object. Right, now to conclude, I don't even have to waste a single minute of time here in order to once again give you the entire history of what a method is, what a function is. All of that has already been done. Let us immediately understand 4 important points with respect to methods in Java. First and foremost, a method, just like a function, the definition is going to be the same. It is nothing but a block of code or set of statements grouped together to perform a certain task or operation. And please be careful here. The task or operation in the context of object-oriented programming languages like Java, it refers to nothing but the behaviors of the object. In the case of student object, we had a behavior called as the eating behavior, writing behavior, reading behavior. And how are you supposed to implement behaviors? Nothing but using the concept of methods. But then this is where the catch is, where most of the experienced developers in the industry also are not aware of this fact. For them, both functions and methods are identical. It is nothing but same. But there is a huge difference where your functions are not associated with the objects, But if you associate a function with an object, that function, you won't be calling it as function anymore. That is what, my friends, is technically referred to as methods. And undoubtedly, a method, just like a function, won't be executed automatically. For you to execute a method, definitely it must be called. Anyways, let us look into the second important point here. This I have already reiterated many a times here. In Java, using the concept of methods, we will be able to implement the behaviors of the object. We are already aware of this. But then, syntactically, if you ask me any difference between functions and methods, most of the things are absolutely the same. The only difference here is, in case of object oriented programming languages, you will have to compulsorily place your methods always within a class. That itself is the third important conclusion with respect to methods in Java. In any Java application, I can guarantee you, you will not see any method that is going to be defined outside the class. Every single method in Java would always be enclosed within a class. That is the reason why, for you to invoke any method, since it is going to be indicating the behavior of an object, first and foremost, you will have to create an object of the enclosing class, and it is through the object reference you will be able to call the method. Anyways, that part with a programming example, we are going to explore it. And last conclusion here is, whatever member variables, the variables that you would have declared directly within a class, we know technically those variables are referred to as instance variables. Any single method that is present within a Java class, it can directly access all of the instance variables that are declared in the same enclosing class. So these are the four important conclusions with respect to methods in Java. Now, next what we need to understand is, what is the definition of a method in Java with respect to its syntax. Now, let us quickly understand what is the syntax of a method in Java. As a Java programmer, if I have to define a method within my Java programs, what is the syntax that I need to follow? Please understand, the method definition in Java will have the same four components of a function as it is. Additionally, there would be two extra components that would be included here. Anyways, please have a look at the method definition here. Just like how a function will have something called as a function name, similarly in Java, a method will also have something called as a method name. And it is immediately after the method name, it must be followed with a pair of parentheses like this. And it is in between these parentheses, we have to specify something called as the parameters of a method. And of course, the most important component of a function or a method happens to be the body of the method that must be enclosed as a block of code like this. And lastly, it is compulsory that every method must also be defined along with its return type, and the return type must be placed just before the method name like this. These are the same four components that a function also had in C, C++ programming languages. But in Java, additionally, there would be two extra components that would be involved here. Firstly, a method in Java can be associated with something called as modifiers. Maybe this term called as modifiers might be new to all of my learners, but definitely a method being associated with modifiers is not the first time that we are trying to explore here. In fact, we have seen one concrete example of a method that is already associated with modifiers that we have been using in every single program, which is nothing but our main method. If you recollect from the signature of the main method, it has been associated with not one. In fact, it has been associated with two modifiers, namely public and static. Those keywords are nothing but modifiers. Basically, why do we have to associate a method with modifiers? If you would like to restrict the accessibility or the visibility of a method, that can be achieved by using something called as modifiers. And the last component, it is nothing but the exception list. And please remember, the sixth component, which is exception list, it is something that you will be able to completely understand only after a concept called as exception handling in Java has been completed. Because In Java, it is possible for a method using the throws keyword, it can declare multiple exceptions. Those exceptions that may or may not possibly be generated within the body of a method. Like I said, if I would go ahead and try to explain that at this point of time, it would unnecessarily create confusion in our understanding. Hence, let us keep it at a later point of time. Once exception handling is completed, that is when you will be able to understand this particular component. To conclude, the summary of all of these 6 components within the method definition in Java, these happens to be the 6 different components starting from what a modifier is. Next, we have got the return type, we have the method name, we have the parameter list, next we have the exception list, and finally we have the method body that is enclosed between braces. This summary is for you to remember, and please understand, like I said, the 4 major components of a method are nothing but the same 4 components of a function that has been inherited as it is.